G'day again, this is the second video for today. What are we? We're the 31st of March. This is following on from the previous video I did around the idea of arithmetic and geometric sequences. Now, arithmetic sequences, we don't have a great application for them, although there are some. But geometric sequences, we have some really specific applications that always come up in questions. So I wanted to work through this sort of idea and give you a feel for how you can use geometric sequences in the questions that you're doing. So, we know this already, okay? I actually forgot something here because with this one, this is a non-recursive equation. Let me start that again. This is a recursive equation, so I must state a starting term. So I must state T1 equals A. I don't know what that number is. That would determine upon the specific sequence. But this is a recursive one, so I need the starting term. This is non-recursive, so I'm okay. I don't need a starting term. Now let's talk about this R value. This R value. That's where the important thing comes in with growth and decay. Okay? Depending upon the R value depends whether we're getting growth or decay. Now if R is greater than 1, remember, R is my constant multiplier. That's the thing I'm multiplying by each time. So if I multiply by a number bigger than 1, then that means that my value or my sequence, the terms in my sequence, are going to be getting bigger each time. If R, however, is between 0 and 1, okay, let's get our numbers, let's get our signs the right way. It would be this and this, because that's saying that R is greater than, crocodile eats the bigger thing, R is greater than 0 and R is less than 1. Now that makes sense. Between 0 and 1, what's going to happen there is the numbers are going to stay positive, but they're going to get smaller. Okay? Think if you take $100 and multiply that by a half, you end up with $50. Multiply that by a half again, you end up with $25. Multiply by a half again, $12.50. And so it keeps going closer and closer to 0, but never gets there. Okay? So this is the, if you've got an R value in here, you're in a decay situation. If your R value is greater than 1, you're in a growth situation. Now let's also briefly talk about what happens if R was less than 0. Well, what actually is going to happen there on a graph, you're going to end up with the first term might be here and be positive. The second term is actually going to become negative because you're multiplying by a negative number. It might be down here. Then the third one might be here, and then the fourth one, and the fifth one, and the sixth one. And it will either be converging like this, or it may be diverging. But either way, it's going to flip positive, negative, positive, negative. Now that's not actually going to be much benefit to us in practical examples. So you're unlikely to see anything like this. But you might be given a graph like this and asked to write the formula. If you see this happening, that's your key that, hey, R's got to be negative in this case because it's going positive, negative, positive, negative. That's just a little extra. Right, back here, growth. Greater than 1, decay, between 0 and 1. Here's a practical example, and it's only just one example, but you'll find ones like this in your book. We've got some house or some unit and it's valued at $100,000 right now. And we know, maybe not in these corona times, but we know that it's growing at 10% per annum. So after 1 year, it's going to be worth 10% more. After another year, 10% more of that. After another year, 10% more of that. So, see N, it's a bit like X and Y here, but see it as N and Tn. So the input number is what I'm putting into my formula, and the output number, what I'm getting out. Or I'm putting the number of years in and I'm getting out the value of the house. Now, in the first one, we've got to be careful here, and this is where I want to make the point, is that those formulas are set up for sequences. Now I'm applying it in a practical sense. Have a look at this. Year 0, that's right now. The house is worth this. I'll just put 100K there. Now after 1 year, it's grown by 10%. So this is actually going to be $110,000 or 110K. And after 2 years, it's this number has grown by 10%. That's actually going to be $121,000. Now this all looks okay, and you might say, well, I can work that out as far as I like. That's okay. You can, but here's the issue. If I take 2, right? If I take 2 years, and I put that into here, right, with 100,000 there and 1.1 in there. Oh, should mention that. This number here is 10% growth. So that would mean that my R value has to be 1.1. The 0.1 is the 10% growth. The 1 says keep what I've got and add 10%. So if you see 10% growth, you're looking at 1.1. If it was a 10% decay, that would be 0.9, okay? 0.1 less than 1. Hopefully that makes sense. I might explain that in another example later. Anyway, so we're here, 2 years. If we take that and put it in there, we would get 2 minus 1, which would be 1. It would end up being, I'll put a little here, I'll rub this out in a sec, but here we go. So if I go T2, that would equal A, which is the 100,000, times R, that was the 1.1, to the power of 2 minus 1. Now 2 minus 1 is just 1, so let me just put 1 there. Now if I work that out on my calculator, I actually get $110,000. But here's the problem. That's not the actual answer. So something's gone amiss here. And what it is that when we're doing growth and decay, see how I've got a T0 term. This is like T0. But I work this formula based on starting with the first term. So my formula is set up to work from here on. But practical questions start at the 0 term. So what I need to do for practical questions is actually here, when I'm using this formula, I actually get rid of the minus 1 part. Get rid of the minus 1. And that resets the formula to start here. So then, if I rework this, I'll do it in red so you see the differences. If I was doing T2, this would be still 100,000 times 1.1. That's the same, but it would be just to the power of n, which is 2. And then this number would come out at 121,000, which would match with what I've got there. So you've got to be aware in practical questions, because we start at T0, we must adjust this formula a little bit. Because that formula was for our sequences that started here. We're now starting one back before, so we get rid of this minus 1 part. Okay? If you can remember that, then they'll work out. Okay? But conceptually, it can be difficult to see. So just be aware of the need to change the formula to suit the question. You're not dodging your mathematics. It's absolutely fine. But it's choosing the right formula for the question. Practical question, get rid of the minus 1. A sequence question where it's just the numbers, leave the minus 1 in there. Hopefully that makes sense. But that's one question that we can get with this sort of idea around the sequences. Right, the second question that's a very common one is the bouncing ball question. You know, it's on a table and the ball gets knocked off the table, it bounces away. Now, it might bounce away, it might just be bouncing on the spot as well. Okay, if I had a basketball and I just drop it, it's going to bounce back to a certain height, and then a smaller height, and then a smaller and smaller. So here's the first bounce, second bounce, third bounce, right? So I'll put first B, second B, third B, okay? So we've got these bounces happening. Now I've said the table was 1 metre high, okay? So it's bouncing off the table so high, no problems. Now I'm going to say that the rebound here, I'm going to say is 0.8 metres. Now I've chosen those numbers specifically because what this is telling me the ratio or the R value. Because see, the height of the table let me call that T0. Okay, and I'm going to set up a little table here, even better still, I'm going to write this as Tn, or actually better still, I'm going to write this as N and Tn. So I'm going to do it like this, okay? So then, what I'm going to do is I'm going to have N as being 0, okay? Call that as 0. This is the first bounce 1, second bounce, third bounce onwards. So Tn is the value of that. So that would be 1 metre. That would be 0.8. And then I can get my ratio is 0.8. So my ratio of one bounce to the next is 0.8. The next one I would have to multiply by 0.8 again. Then what I'm going to get is 0.64. Okay? And onwards. So the next bounce, this would be 0.64. This would be 0.64 times 0.8. Okay? Now, once I've got some figures like that, then the question might say, what distance had the ball travelled when it arrived at its second bounce? What distance has the ball travelled when it arrived at its second bounce? So we want to know this distance plus to get to there. So wouldn't that be, well, it's one lot of the drop, so it's going to be 1 metre plus, up to the height, that's 0.8, down again, that's 0.8, and up again, that's 0.64. So if I add that together, what do we got? 1, 1.8, 2.6, 3.24. 3.24 metres would be the distance the ball has travelled when it arrives at its second bounce. Maybe someone catches it on the second bounce or something like that. Okay? So this is a practical example of how you can see things going on. Okay? Similarly, notice how we started at 0, right? That's just like this one here. So if I wanted to write a formula for that one, I've got to get rid of this minus 1. The A value is going to be 1. The R value is going to be 0.8. And I get rid of the minus 1. So you could write a formula that describes this, and that will get you these numbers here. Now there is a set of formulas. They're called geometric series in this case, or arithmetic series, where the formula will actually add all of these up. Now if you want to have a look, they're in my Year 11 methods stuff. It shows you how to do arithmetic series and geometric series. It's not required in the apps course. But if you're a top student and you're looking for that really top mark, being able to do the arithmetic series and geometric series will help you. It'll be a little quicker. Your calculator can do a lot of the number crunching, but you've got to understand what you're doing. So have a watch of those videos if you want to. They will help you to understand more around this idea of adding things together. Okay? Hope this has helped. I just thought growth and decay is an area that often people struggle with. And on all of this stuff, all of this sequence stuff, we come and revisit this later on the year in our finance section. So if this is not good for you, finance is going to be a struggle. Okay? So please make sure you're understanding what you're doing. Hope you've enjoyed this video. Catch you later, guys. Bye now.